All right. So Pawsey. Pawsey is National Supercomputing Center, which means that we are federally and state funded to provide resources to researchers from higher education institutes like all the universities, but we're also a joint venture with the CSIRO. So we also provide resources to researchers in CSIRO, state government, and occasionally if you're a part of a commercial venture that also has partnering with state government or with any of our partners, you can also gain access to Pawsey that way. And Supercomputing Center covers a lot, but essentially it's high performance computing, so parallelized code. You'll see in the picture here that's our previous supercomputer called Magnus, which has over 30,000 cores, all set up to specifically run highly parallelized software. We also have things like high memory compute, so that if you have a particular type of workflow that requires a lot of memory, more than you might be able to, say, get on your laptop or your local system, we can accommodate that. We do visualization, we do data storage, which we've already discussed. All the things that might be necessary to allow researchers to conduct their research that are out of the ordinary, that's in that you can't do it on your laptop, you can't do it on your local university infrastructure. So we facilitate that. What we'll be talking about today is, it's a relatively new part of Pawsey. It's called the Research Cloud. And we've called it Nimbus. So you may or may not be familiar with cloud. Everybody's of course heard the term, but I'll run you through just an introduction to what that actually means, and how you can get access to it, and the types of things that it might help you to do if you feel like applying for it. So, okay, Pawsey. We take frustrated researchers, like our pal here on the left, and hopefully turn them into cool cats. As I said, we provide a number of facilities. If you don't have enough processing power, if you don't have enough memory, if you don't have enough storage, if you need to parallelize, if you need access to GPUs, which is more of a modern trend. So if you're doing things like machine learning or artificial intelligence, and you need access to a lot of modern GPUs, then we can facilitate you as well. Just a couple of quick quotes. So Chanua Tremblay is part of CSIRO, and she's a radio astronomer. And for her survey, she said if she'd had to do it on her laptop, the amount of analysis that she's currently doing on Pawsey, it would have taken 25 years. Whereas for something like the Malura Wide Field Array, which is the MWA, another radio astronomy survey that Pawsey has a direct link with, they collect a petabyte of data a month, and they've already stored over 40 petabytes of data at Pawsey. So just a couple of examples, the obvious examples. There are obviously more, but that's kind of an indication, introduction to the sorts of things we do. Okay, so cloud, where does that fit in? I said you're probably very familiar with the term cloud, but what does it actually mean? So I wanted to explain in terms of an analogy. So a few years ago, probably more than I'm willing to admit, if you wanted to watch a movie at home, you bought a DVD player, you bought a DVD of the movie you wanted to watch, and you had your TV set up, and you'd sit in your lounge room and watch it. And if you wanted to watch another movie, you had to buy another DVD. If you wanted to watch it in your bedroom, you either had to pick it all up, take it off the wall and take it into your bedroom, or you had to buy another DVD player with another TV. And the same if you wanted to go to a friend's place. Now, of course, you can just get an account from Netflix or, you know, Amazon Prime or whoever, and you get an account, you log into the web page, the Netflix web page, and you've got all your accounts there, and you can choose any movie you want, and you can do that from, you know, your smart TV in your lounge room, or you could do it from your iPad, or you can do it from your phone, anywhere around the world. And you can, you know, you can sit there with friends. You can do it at a friend's place if you wanted to. So this is roughly the analogy I'm trying to get across. Previously, if you wanted to do research, you had to buy the hardware, you had to buy the computer, you had to set it all up, you had to have all your storage, and you managed it. And if you wanted to do more, you'd have to buy more. So the cloud is where someone else handles the hardware. So in terms of Netflix, someone else has bought all of the hardware, the machinery to serve up all of the movies. And all you have to do is log in through a web page, and then you get access to all of that. So that's how a research cloud in effect works. We, as Pawsey, provide all of the machinery. So we have the computers, we have the networking, we have the storage, and we put some software on top of it so that you can access it all through a web page that lets you look at, you know, let's have a look. So here we go. This is an example of some of the pages that you can see from your home page once you've accessed Nimbus, our research cloud. So it can show anything from over here. We have an overview page, which is essentially like telling you what your account is on Netflix, but it tells you how many virtual machines you can create, how much memory you can allocate, all these kind of administrative things. You also have security, you have management for your network, and you have management for your volumes. Okay, so this is your home page, if you like, for administrating your project on the research cloud. To actually do your work, though, sorry, I've jumped ahead of myself. So in order to kind of temper your expectations as to what you can expect from a research cloud, there is kind of a cloud service model that people use in the enterprise. It's not as clear cut as these kind of three tiers, but it lends itself to helping you understand. So at the very bottom, we just have infrastructure as a service. In other words, someone else provides, they have all the computers, they have the network and the storage, etc., and they just provide essentially bare metal. And then you're responsible for doing everything else. You have to install the software, you have to manage it. If something goes wrong, then that's your problem. Okay. Above that is platforms as a service, where they provide not only the hardware, but they provide the networking, they provide the operating systems. They will quite often provide software, and then you are able to log onto it if you've got an account, and you utilize all of that to create your own programs or to develop your own APIs, whatever you want, these platforms. And then finally, the top tier is pretty much, they provide like a scientific portal, if you like. If you've come across those before, they've given you everything, all of the software that you want, all of the workflows and the pipelines are all there, ready to go. All the data is there for you, so you simply go on and do your job and then take the results of that. So those are kind of three crude tiers, if you like. Now, in terms of Nimbus, we are pretty much infrastructure as a service. Okay, we provide you with the compute and the storage and the networks all set up, but what you do with it is up to you. Okay. Which means that you do have a responsibility, because obviously you've got to be able to set things up, you've got to be able to install software and learn how to run it and kind of diagnose when things go wrong. But it means you have incredible flexibility, because you are able to, you're not confined to the, you know, a particular operating system or a particular version of software. You can manage it as you will. Okay. We do provide, obviously we've as you saw from the previous slide, we do provide some kind of orchestration, if you like, what we call OpenStack, so when you first log in, a network is automatically set up for you. Storage is easily available. Okay, so we're kind of in between platforms as a service and infrastructure as a service, but we don't, certainly not at this stage, we don't provide software as a service. Okay. All right. So how do I interact with my virtual machine? How do I interact with the cloud? We've already seen that you can do administrative stuff and project management stuff through a web page, but by default, you interact through a command line interface. So in this case, you can see I just got onto my Windows machine using Windows Terminal, and with the command line interface, I interact with a machine that I've created on Nimbus Cloud, and then I give it commands, and it performs those commands all in terms of command lines interfaces. So if you're not familiar with that, and lots of people aren't, then it's a challenge at first, because it looks like double the good to you and you're just not used to it. But it is, once you have a little training, a little practice, it's an extremely efficient way to actually work. So don't be put off by it. Okay, we give instruction on how to do it, and there's documentation on how to just do minimal things you need to get by. I'd never done it before, and then I started my PhD and shifted from kind of Windows systems to Unix systems, and I had to learn it. And by the end of my PhD, I wouldn't have gone back. It's so efficient when you get used to it. Okay, so that's just a couple of examples of what it looks like. Certainly what it'll look like to you initially, okay, will be these command line interfaces. But if you take it a little further, you can use a number of things, tools that are out there that allow you to have more of a graphical interface. And you might be familiar with some of them. Jupyter, so you have Jupyter Lab, you can have Jupyter Notebooks, you can have Jupyter Hub. So these two images here are examples of people using Jupyter Lab. So they're often a lot like a web-based IDE, if you've ever used that for different programming languages. So you can have different tabs and you can set it all up. And this is, for a lot of people, this is more familiar territory than using a command line. You could also use this bottom one over the left here is Rstudio. So if you use the programming language R more commonly, then there's all those available. You could also use remote desktops if you've ever done that. So these are available, but we don't set them up for you. So you need to set them up if you wish to use them. Okay, so you are not stuck necessarily just using command line. If you're more familiar and you'd prefer to keep using it and you like the functionality, you can certainly set these things up on Nimbus Research Cloud. So what can we do in terms of research on the cloud? Well, I mean, there are no limits. It comes down to the fact that, we're essentially just providing you with computing hardware. So anything that anybody does in terms of, research computation, you can do on Nimbus. So these are just 3 examples of projects that use Nimbus as part of their projects. So, using fish to teach underwater robots to swim. We have done some great work with health sciences. So there's a project that actually streams data from NICU units for babies, premature babies, streams it to our research cloud, and then uses a machine learning algorithm that they developed to identify health problems in premature babies. Yeah, the cloud can do anything you want. It should be thought of as, I mean, if you think of your laptop as a certain level of, you know, of processing power and capability, the cloud, a research cloud, is kind of the next step above that. And we often say that the research cloud is a good entryway to high performance computing, because our big supercomputers, you really need to be able to prove that you've done that kind of high performance computing before. And one way to do that is to show that you've used successfully something like the research cloud, Nimbus. So yeah, if you think of it in terms of tiers of capability and resources, then you'd have your laptop, and then maybe the university, and then a research cloud, and then obviously high performance computing things, so Magnus, our new supercomputer, Photonics, those types of things. And that's about it. So I've got up here links. Applying for access, if you think you'd like to get a project started on Nimbus, there's a link to the application portal for that, or sorry, documentation on how to do that. We also have all of our training resources, including an introduction to how to actually get started on Nimbus. And we also have a YouTube channel with video records of those kinds of training sessions.